Alright, my name is Patrick Holland. I'm a student at the University of Victoria, and this is a demonstration for a project that I did for the class Computer Science 462 Distributed Systems. Yeah, so earlier in the semester we had a handful of people come in and give talks during our lectures. They were people from industry who had problems or are currently working on solutions to problems that a distributed system would be ideal for. So one of the people that came in is the head of a naval architecture firm. So they're building these boats. Some of them are pretty massive, and these boats, they have a ton of parts. So they want to be able to keep track of the parts that they are using in the boats, and they want to be able to have a database that they can read from that contains ideally all the parts from different manufacturers. What this really boils down to is that they need a massive database. This database must be able to scale really easily. The important operations would definitely be reads from a performance perspective, and writes from a reliability and consistency perspective. The main tools used in this project were MongoDB, Docker, and specifically Docker Swarm, AWS, and we have a web app with an API that's running on Nodejs and Express. So for MongoDB, when you are clustering your database, like in a distributed system, the required components are a router or multiple routers, a config server, which is replicated, so it's made up of 3 nodes, and then as many shards as you'd like. So the shards is where the data is stored, and the shards are also replicated, so each shard is made up of three nodes ideally. It could be more, it could be less. This diagram here shows the different services, so the different Docker services that we'll be running. So here we have 3 web app slash APIs. So it's one service that's replicated 3 times. So there's 3 different containers on 3 different hosts, just to increase availability. Same with the router. The router is the same thing. There's one router, but it's replicated 3 times. And then for the config server, there's three services that make up the config server. And then each shard has the same idea, where it has these 3 services connecting. They're basically replicating the data, and they make up a shard. This diagram shows how the services could be spread out across different AWS nodes. So ideally you'd have each of the shard services on their own host. So each one of these clouds represents one AWS node or AWS instance. And because the shards are actually storing data, you'd kind of want them to exist by themselves within their AWS instance, whereas these other things, they're not storing data and they're not really that computationally intensive, so they can kind of share a node. So this is the AWS dashboard, and this is showing all of the AWS instances I currently have running, and there's 8 here, which is the setup that we showed in the previous diagram. So to start, we're going to want to set up the Docker Swarm. So we're going to have to SSH into one of the AWS instances and initialize the swarm, and then log into each and every one of the other instances and join the swarm. So we'll SSH into this one, and then start the swarm up. So now we have this command here, and we just copy this command and then SSH into each of the other instances, paste that command, and it'll join the swarm. So here we're SSH into a second AWS instance, and we're going to join the swarm this time. So we'll put sudo, and this node joined a swarm as a worker. So we're going to do that on every other instance, but I will not show that. So we've joined the swarm on every one of those AWS instances, and now we're back on the first one, so the swarm manager, or the leader. So we can list all the nodes here. We see that this is the leader, and this is the one we currently are. And there's all 8 of them here. Now we're going to want to deploy all of these services across the swarm. So we'll cd into our proper directory, and we will run this start cluster script. Let's try it with sudo. So here we go. It's building the Docker images, and now it is creating all of those services. So these services will be placed across the entire swarm. And now they're up. So they have a bit of some setup to do here. For example, this is the Mongo 0, so this is the router, but this is the actual router. This is just the setup service, so this service will just run a setup script to set up the router, and then it'll die. But this will take a minute or two. Alright, so let's check on the services. So the configuration or the setup services are now down, which probably means that it's fully up and running, so we'll test it out here. So connecting to the Mongo client locally has connected us to the Mongos, which means that it's a router and not a database, which is good. That's what we want to be on. So let's check on the sharding status here. So we currently have one shard, shard 0, which is what we'd expect because the start cluster script only starts up one shard. And we can see that the databases that are currently being sharded is the boat database, and there's a couple different collections here. So we have the boat parts collection is being sharded, and the boats database is being sharded, or the boats collection is being sharded, and the parts collection is being sharded. So one of the services that is currently running is our web app, and it's being replicated 3 times, so it should exist. Its service should be running on 3 of these AWS instances. But one of the really cool things about Docker Swarm is that you could request that service from any one of these instances, and as long as they're part of that swarm, they'll know which service you're targeting. So we select one of them randomly, we put in its IP address. By default, this is port 80 HTTP, and we get the website. So we could take any one of these, and we'll be able to get the website, even though it's probably not hosted on that specific instance. So as I mentioned before, we currently only have one shard running. So let's go ahead and add another shard, and I have a script that makes it really easy. It's the add shard script. So we say shard equals 1. Oh, sorry, let me sudo that. And here we go. So we just started, it's starting the services, the 3 replica set services, and then its setup service. So this will set itself up as a replica set, and then it'll add itself to the cluster. Alright, let's go ahead and check on that and make sure that it got added to the cluster. So we'll go back into the router and do sh.status. And now we see that shards, that there is 2 shards. There's S0 and S1. So it got added successfully. Our cluster is up and running now, but we need to write some data into it because the database is currently empty. So I have a Python script that I will run locally. So this is running in my own terminal, and it'll just fill the database with a ton of data. So let's run it. Alright, this will take a couple minutes, but we'll check back after. The way these writes are working is it's just using an API from the web app. So I plugged in one of the IP addresses from our cluster, or from our swarm, and then it's just using this /API /write /mongo /part, and then each one of these, there'll be post requests, HTTP post requests, and each one of them will have an object attached to them, which will be the object that we want to write into the database. And we have 2,500 rows of sample data, and so we're just duplicating that 50 times. The Python script is still running, so the writes are still happening, but let's go ahead and check see how it's going. So we'll go into the boat database, db.parts.count, so just see how many exist in there. So currently we have 45,423 rows of data in there, and now let's check. So it's still going, 46,000. So we'll come back to it when it's completely done and check how many have been written. So I messed up a little bit and had some data already in the database before we started, so the numbers don't quite match up, but we just did 126,000 writes, And if we do, so we count them, and we have 139,000. So the numbers are a little bit off. But if we were to take, we'll query for this row here, this row, and we'll make sure that there's 50 of them. So we'll do db dot. So this query should return 50 different, yeah, so it's a bunch of them here, but not all of them, so let's just count them, and we got 50. So we did, we took this CSV file with 2,522 sample rows of data. We duplicated it 50 times and wrote each one of them into the database. And now let's go ahead and take a look at the sharding distribution. So we can see that shard 0 has 8 megabytes of data, whereas shard 1 has 24.8 megabytes of data. So it's not quite even, but the thing is that the data that we actually put into the database is so small. Like the average object size is 266 bytes, so it's not going to be too concerned with evenly spreading it out, because the data is not filling up the storage space yet. And if we had more shards showing, and maybe a lot more data, or data with bigger file sizes or bigger object sizes, then we could see a better example of how the shards distribute the chunks. So that was a quick demo of our project, which is a distributed database using MongoDB. So it's a MongoDB cluster running on Docker Swarm and using AWS instances. It was a really cool experience, and I don't know, hopefully I can get some more opportunities to work with distributed systems and AWS or Microsoft Azure, stuff like that.